So this is an illustration that we've used many times before for crossing over, and it looks different to the crossing over illustration or model that was used in the question that you gave. If it asks for a diagram about crossing over, then all of the questions that I've seen so far in the exams that we've looked at, this is fine to use. So I would first draw that. The fundamental ideas that we need to get across about the differences between those two, I'll outline in more detail, but the three key points that I'll go through is one, DNA replication that occurs in interphase before even this illustration gives you sister chromatids. Two, that the tetrad only overlaps and crosses over with one set of those sister chromatids. And three, that the recombinant daughter cells, daughter chromosomes that occur at the end of meiotic division 2, and those four daughter cells, some have recombinant chromosomes, and some have non-recombinant chromosomes. Or another way of saying it, some are the exact same as the parent chromosome, and some are not. So let's go into a bit more detail. So from this illustration is what I would use in your example, in your answer. You'd have to initially say that these sister chromatids initially formed from DNA replication of the parent chromosome. So parent chromosome, and now we have sister chromatids of that chromosome. And same thing here, parent chromosome, and that could just be illustrated with an arrow. And now, after DNA replication in interphase, even before meiotic division 1, we now have sister chromatids of this chromosome. Now we get into prophase 1, and we have a tetrad forming, and the other difference now, one, they didn't show the DNA replication and the formation of these sister chromatids. Two, in the model that was shown, they didn't show this tetrad, so keyword. They only showed this section in the middle. So we still have two sets of sister chromatids that are not crossing over, and that's significant to maintain genetic consistency. After crossing over, now we get to the end of meiotic division 2, and we have our four daughter cells. As similarly to the model that was given, we have the two recombinant chromosomes now showing variability and variation in their in the chromosome, but in a different way. And the most significant thing here is we've got non-recombinant chromosomes, one here and one here, that are the exact same as the parent chromosome. And therefore, instead of having all chromosomes crossing over, some can and some don't. So therefore, depending on fertilization and what sperm meets what egg, any of those four, either with that genetic variation, could be used for fertilization and zygote production, or similarly, it may not, as opposed to the model that only showed that genetic, the crossing over occurring and recombinant chromosomes being used. So, three things you would need to look for and highlight in that answer. One, genetic variation initially needs to come from DNA replication in interphase before even this process is occurring before even meiosis division 1, therefore giving you sister chromatids here in this chromosome 1 and sister chromatids in this chromosome 2. Then in prophase 1, we have crossing over occurring at the chiasma. But in the same way, there's no crossing over here with this one nor that one. Therefore, the daughter cells, the 4 daughter cells that occur from this crossing over process and the occurrence of the tetrad is 2 recombinant chromosomes and 2 non-recombinant chromosomes. Okay, I hope that helped.